Okay. Yes. Volume is nice. Cool. So I guess we'll get started and hope more people filter in from the talk out there. And so, hi. I'm Matt Topol, and I'm going to give you a nice... That was really loud. And I'm going to be talking about Apache Arrow and the whole Apache Arrow ecosystem, the tools, the libraries, everything that's built up around it. So before we get into that piece of it, maybe you should just figure out why you should actually give a crap what I say. I work as a software engineer at Voltron Data, which is currently the larger corporate presence behind the open source Apache Arrow project. There's tons of contributors, tons of people involved. Voltron Data is very big into that area. We're a startup. I also get to say I wrote the book on Arrow, because I did. There's only the one. You see it right there. And if you're really interested in Arrow, go check out my book. So I'm also on the Apache Arrow PMC, the Project Management Committee. So I'm very heavily involved in actually developing the project, trying to build the community, and so on. Arrow started about in 2016-ish, and it was co-created by the same guy who created Pandas. So let's get moving. Okay, so what is Apache Arrow? So Apache Arrow is a very high-performance, column-oriented in-memory data format. It's a spec and has implementations in a whole host of different languages. I didn't even list them all here. There's more than what's listed here. Now, the idea there being that the representation, the way it's laid out in memory, is identical to the way it is on the wire, which means that you don't have to pay serialization and deserialization costs every time you're passing data back and forth from systems. You can see if you look at this over here, every time data is going from this system to that system and around, you have to copy it, you have to convert it, you have to go from JSON to protobuf, because all the different systems have different ways of representing data. Not only that, but they have different wire protocols, different communications. Whereas if everything is just talking using Arrow as the data format, you can get zero copy communications. You're not paying serialization, deserialization overhead every time data is going from one component to the next. Now, if you're not familiar with column-oriented or columnar, it's very simple to understand. It's kind of the struct of arrays versus array of structs mentality there. It's how your data is actually laid out in the actual raw memory. So in the example I have here, on the row-oriented memory side, the left side, you can see that each column value in contiguous memory is one column, the next column, the next column, one column, next column, next column. And it's how it is in memory. Whereas column-oriented puts all of the data for a single column in a contiguous chunk of memory. And so if you wanted to go row by row, you're grabbing row, then row, then row. But most analytics use cases, most data usage nowadays isn't very row specific, unless you're doing very transactional row only. You want all the columns for one row at a time processing, which is increasingly rare. So what you get out of column-oriented is lower I/O. You'll get lower page faults at the memory CPU level, because when you're processing and running through a column, that's the next chunk of memory as you go. And so the CPU can buffer and benefit from the lower level caches. And the cache memory is all right there. Page faults are reduced. Now, that's kind of common with a lot of analytics use cases, a lot of passing data around. In addition, if you wanted to compress data, the fact that all of your data of the same type is in one contiguous chunk of memory means it's going to compress better. And that's where you get things for file systems on disk like Parquet. The other benefit is actual computation analytics. If you're familiar with the term SIMD, single instruction, multiple data, vector instructions, vectorized computations, being able to compute at the CPU level and do a analytics arithmetic computation across multiple values of data with a single CPU instruction. One of the requirements to utilize that is that the data has to be contiguous in memory. Because what's doing is the CPU grabs chunk of bytes, puts it in one register, chunk of bytes, puts it in another register, and then does the operation. So if in a typical row-oriented data approach, if you wanted to benefit from vectorized instructions, you have to copy the data from the column you want into another area of memory so you can get it contiguous so that you can run the vectorized instruction. With a column-oriented data memory, then it's already in that contiguous format, which means you can very much benefit from those vectorized instructions. And most of the Arrow, and a lot of the Arrow implementations do leverage those vectorized instructions. And a lot of things that use Arrow use those vectorized instructions because it makes it really easy to benefit from that. So, what is Arrow actually useful for? We've gotten past what it is. You know, it's a data format, it's a spec. So what can you do with it? Well, one example is you can read and write those column-oriented storage formats really efficiently. Arrow has an IPC format, for communicating Arrow data across systems. Now that is a streaming format, but it also has a file format. And the benefit of the Arrow file format is that it's memory mappable. You can mmap it, which means it's really, really convenient if you want to operate on larger than memory data sets. If you have a data set as an Arrow IPC, it's also referred to as feather is the format file, then you can have your 100 gigabyte feather file. And you want to process one column from that data. Using mmap, memory mapping, you don't actually have to read the entire file into memory. You're only going to read the memory bits you need. And that works because the raw bytes of the file, the raw bytes of the format, are exactly how it would be laid out in memory. You don't have to decode it or deserialize it to read the Arrow IPC file. Parquet is a column-oriented storage format, file format. One of the big differences between it and Arrow, why you would use Parquet for file storage and long-term storage versus Arrow for in-memory, is that Parquet does a bunch of compressions and encodings so that the data can be smaller on disk. But the drawback to that is when you have encoded and compressed data, you can't operate it on it as is. You have to decode it first. A lot of the libraries that work with Parquet data will decode it into Arrow formatted data because they're very, very similar. They're both column-oriented. They have similar type systems, not exactly the same, and are very interoperable. And one of the other benefits is in certain cases, you actually can just take the raw Parquet bytes and use it as an Arrow array. And so you can get some benefit from the zero copy areas. Several of the Arrow libraries also have a dataset library as part of the implementation so that you can have easy handling of multi-file data sets, which then gives even more benefits when you're trying to handle larger than memory data. It'll handle, multiple multi-file remote or local data sets for you, predicate pushdown, filtering, and so on. I'm going to get more into that later. Now, I mentioned the Arrow IPC memory mapping. There's both the case of handling it on disk when you want to write a feather file or when you're passing it back and forth between your processes, because it makes it really easy to pass the Arrow IPC format across a wire, because like I said, the bytes are the same. But Arrow also defines a C data interface. What that is, it's going to enable you to take different runtimes, like say Python and C++, and you can allocate and start your data in Python side. And then you can pass that to the C++ side without having to copy the data in between, because it's just going to hand off the pointers to the raw buffers. But not just the Python C++. What about, say, Python to Java, or C++ and Go, or Go and Ruby, or whatever else you want to think about? The fact that it has a C data interface allows that zero copy in-process communication between runtimes and between different libraries and between different uses. And I'm going to show how that gets used in some examples later. So the other big aspect, and as I've mentioned many times, is the fact that when you pass Arrow across a wire, you're not, the data is the same on the wire as it is in memory, making it super fast for data transport and data interchange. The big idea here being that if more and more systems operate on and speak and use Arrow, everything becomes more interoperable, becomes more modular, more composable. Your larger data system is more efficient because you're not having to change and transform your data at every step in between. And that then gets really, really big and really, really useful when you're building pipelines, ETL, ELT, whatever your data pipeline is. Whenever you're passing data and shipping it around, you're going to get benefits if you're using Arrow the whole way through. Now, everything I've been talking about is the Arrow format, the spec, the way it's been built and how you implement it. Around that is the Arrow project, the actual github.com Arrow, Apache/Arrow. In addition to the format and the spec, the project has been built up around it with the community. And over time, Arrow started back in like 2016 or so, it has become more popular and more used, more widely used. As of beginning of October, there was over 12,500 stars on GitHub. As of the beginning of October, there was more than 900 unique contributors that have committed to the Arrow repo. It has a very large community and a lot of people that are contributing, using, benefiting, and making it better. So it's a very, very active project. The Python Arrow library, PyArrow, in September alone was downloaded from PyPy more than 75.5 million times in that 1 month. This is a very active and very widely used project, and part of my goal of being here and talking about it is to continue to expand that. So I'm going to tell you, so hopefully my beginning part when I talked about the format kind of intrigued you, made you want to use it. So now I'm going to talk about how you can actually use it, what you can do, what exists in the ecosystem to help you benefit from this. So there's a number of sub-projects with Arrow. There is Arrow Flight SQL, which defines a framework for RPC protocols organized around streams of Arrow data, and the Flight SQL, which is actually a full wire protocol for interacting with databases where you're getting your data results and your data formatted as Arrow data, and it goes across the wire as Arrow. There is Nano Arrow for certain scenarios where you need something really, really small, and you're not looking to do a lot of work or data manipulation on the data. You just need to be able to receive some Arrow data and use it, or send it further down the pipeline, or just read it or something like that. There's Nano Arrow. It's a very, very small venerable C library that is an implementation of the Arrow format. For a good example of the usage of the Nano Arrow, the Snowflake's Python connector recently released, exchanging their backend from using PyArrow, which comes with all the baggage of the C++ library of Arrow and all of the extra compute functionality that exists in that library that they didn't need in the Python connector. They just needed to be able to read Arrow, process it, and pass it off to Python. So the Snowflake Python connector recently switched to using Nano Arrow. And one of the big benefits is now that connector can be used in AWS Lambda functions, because previously it was too big. AWS Lambda functions have a limitation on the size of the image. And by switching to Nano Arrow, now it's small enough that you can use the Snowflake Python connector in a Lambda function because they use Nano Arrow. Because Snowflake is using Arrow to pass the data across the wire because of efficiency. Then you have Data Fusion. Data Fusion is another sub-project that is actually currently considering becoming a separate top-level Apache project, which is a full distributed compute query engine written in Rust that uses Arrow as its complete in-memory representation. It even has a distributed coordinator that they call Ballista. It is very efficient, very performant, very useful. Drop in and benefit from it in process. Finally, Arrow database connectivity is a client API specification for interacting with Arrow data for interacting with databases using Arrow native data. I'm going to get more into that later, and there's a reason why it looks kind of like ODBC or JDBC. There's also the possibility that you're already benefiting from Arrow. You might already be using tools and utilities and libraries that are using Arrow, because Arrow as a data format tends to be a lower level thing. And so there's a lot of things that already are using it. Like I said, it's a very popular, very in-use project. Okay? If you're using pandas or polars, you're using Arrow. You know, the entire polars library is built on the Rust Arrow implementation that they built on top of that to build their APIs and the data frame library of polars. They're using Arrow as their memory format. If you use QDF or NVIDIA Rapids, that's Arrow data format on the GPU. If you're querying Dremio, Dremio's entire internal memory format is Arrow. Google BigQuery allows you to return data in Arrow. Meta's Velox open source compute engine, DuckDB. They have internal representations of data that are very, very similar to Arrow and in many cases identical, allowing you to get zero copy communication with those databases. And so on. Arrow is widely used already, but it's not as widely used at application levels or not as widely known about as we would like it to be, because standards are more useful the more people that are using it. Okay, so that was a lot. Covered a lot of things, spoke a lot, said a lot of things, did a lot of stuff. So how can you actually use it in your project? How can you right now benefit with whatever you're doing? Here's a few examples. Let's say you're using Spark. Well, normal Spark handling, you have your Python application if you're using PySpark, and you want to take your data, send it to Spark, do something with it, and you want to get it back. Every time your data goes from Python to the JVM, it has to be serialized on one side, copying, sending it across, deserialized, copying again, processed, and go all the way back through. So you're copying the data, goes here, goes there, copy it, deserialize it again, deserialize, go there. Or Spark has a configuration setting that you can tell PySpark to use Arrow under the hood. And suddenly, there's no serialization here. You're just passing the raw bytes. In fact, you're not even passing the bytes. You're passing pointers. No copy. Just goes from Python to Java without a copy. Just the raw bytes, just pointer to the bytes. Now, remember I said I wrote the book on Arrow, there's just the one? This explicit thing has an example in the book showing exactly how you can do it, what the config function, what the config setting is, and a full example with some data set showing the performance difference. Okay, so now I mentioned Arrow Flight. What is that? It's a framework for RPC protocols, right? Well, why is it beneficial? Well, your typical server situation. Oh, there's a mouse. Hi. Your typical server situation. You got your authentication, your query comes in, you execute it, you start serializing the result. Maybe you start streaming the result of the serialization out to the service, to the client, so that you can get some performance and parallelization. But then it still extends a bit further before the client actually finishes deserializing it. In the case of Flight, it's all organized around Arrow record batches, Arrow streams of data, which means that entire serialization, deserialization step is cut out. And therefore, the overall time of the system of the request is significantly faster. In addition to that, because of the way that Arrow Flight is organized, you can benefit from very parallel data access. The way that Arrow Flight works is that it returns a list of endpoints first, and then at those endpoints, they can be queried for a stream of data, which means if you have a server situation with 1,000 nodes, and your data is split across those 1,000 nodes, you can return the list of endpoints to those nodes to your client, and then the client can control the parallelization of retrieving the data themselves, or in fact send it across their own cluster. Which means that you also can get very balanced parallelization, even if the clusters are not the same size. There exists implemented drivers for JDBC and ODBC that use Arrow Flight SQL or Arrow Flight as the royal protocol. Now, the big difference and the big reason why that happens is because increasingly more and more computation engines, database systems, and work is column-oriented because it's more performant. The vectorized stuff, everything I talked about earlier. But in the traditional use cases, you have your column-oriented data coming from the database, and then, coming from the database, over there, sorry. And then when you want to pass it across a JDBC or ODBC connector, you have to transpose the data from column to row oriented. Then it goes across the wire. And then because column oriented is more efficient for a lot of analytics and computations and data systems, and a lot of data frames are column oriented, you end up transposing it back to columns. So now not only are you paying a cost of serialization and deserialization, you have to transpose the data, which means that the larger your data set, the more benefit you're going to get out of Arrow Flight, because there's no time spent in that transposition step. And a large data set costs a while to transpose, especially because you're doing a copy of the data. It's a lot of allocations. And you can already benefit from this. Like I said, there's already a Flight SQL driver for ODBC and JDBC, which means that if you're a database developer or a data system developer, and you want to have clients access your data in your system, if you expose a Flight SQL interface for your system, for your database, for your servers, you don't have to provide a custom client. It exists already. Your clients already can access it easily with ODBC and JDBC if they really want to. And the transpose step only happens on the client side if they're using ODBC and JDBC, or if they want to access it directly with Flight SQL, they can bypass the transposition altogether. It reduces the work for you as a developer because you don't have to make a bespoke client to distribute. There's an open source work from the Arrow community for a Flight SQL adapter for Postgres. It's a plugin so that you can have a Postgres server, add the plugin, and now you can access Postgres just as efficiently through Arrow Flight SQL. It'll transpose, Postgres is row-oriented, so it'll transpose your data into column-oriented before it sends Arrow Flight, but you only have that one transposition, and you get the benefits over the wire of the Arrow Flight, of Arrow's protocol hours format, and on the client side, you get the benefits of just slurping in the bytes as is. You don't have to convert the Postgres wire format into something you can use. Then there's other things like Grafana added a Flight SQL plugin. Well, specifically, it was donated by InfluxDB, because InfluxDB internally uses Arrow, and they use a lot of Grafana, InfluxDB exposes a Flight SQL interface. So they added a Flight SQL plugin to Grafana so it could access Flight SQL servers. And now you can, and it just works. So, Arrow database connectivity. I said I was going to come back to this, didn't I? God, you guys are so quiet. Like, laugh, come on. Okay. Arrow database connectivity. If you are familiar at all with how ODBC or JDBC work, they work by providing a single client interface. So you can code against the one API, and you swap out drivers to do the different backends. ADBC is the same idea. You have a single client interface that's Arrow native, and expects Arrow. You send in Arrow data, you retrieve Arrow data, and then you swap out drivers, do the different implementations. There are bindings for that API in a bunch of languages already. Ruby, R, if you want to use R with Arrow, really easy. Go, Python, you like my images there? I had a lot of fun getting these made. It's so great. I got stickers of this one if anyone wants. I get stickers. Come see me. C++, Java, C. You know, the bindings already exist. But because it's a C API specification, anything that can interact at a level of a C API can use ADBC if there aren't already bindings for it. Now, you might be thinking, okay, why Flight SQL and ADBC? What's the difference what I'm talking about here? The idea here is that ADBC is your client side. It's the API that the client interacts with. Flight SQL is wire protocol. There's a Flight SQL driver for ADBC, just like there's a driver for ODBC and JDBC. It's a wire protocol. If you build a service or a server and expose Flight SQL, your clients, regardless of what they use to access it, get to access your data via ADBC, JDBC, ODBC, a straight Flight SQL client themselves, and you don't have to build them a client. You don't have to build a custom client for your database or your service or your system. It just works. There's already Snowflake driver. There's already a Postgres driver. DuckDB added an implementation of the ADBC API into the DuckDB library because DuckDB is an in-process database. So when you load DuckDB, you can just communicate via that C API. And then they tested it. And they wrote a blog post. Now we're talking about DuckDB, which means in this benchmark, there's no network involved in this benchmark. This is all in process. This is just the cost of taking the data from that TPCH table, passing it through the ODBC protocol for DuckDB to read it, and then selecting that data back from DuckDB, and DuckDB returning that data using the ODBC protocol. There's no network, no wire here at all. It's all in-process communication because DuckDB is an in-process database. When they tested the ADBC interface that they implemented, the ADBC driver, look how fast it was. Like it's ridiculous. And it shows that the big cost here is that transposition. It's the data copy, allocation of memory. All of those things are being eliminated by using ADBC and using Arrow, and that's zero copy C data interface. It's all about interoperability. Arrow is key. Arrow is built on this interoperability idea. The more systems, the more compute engines, the more services that use Arrow as their format of choice, or even just expose Arrow as an output format or accept it as an input format, even if they're not using it internally, the more useful it is for everyone that uses it and benefits from the performance benefits. Now, sometimes things change, and as I mentioned, DuckDB and Meta and Velox, their internal representations are similar to Arrow in a lot of cases, and in a lot of cases identical. But in some cases, because of research that they had found and done and tested, there's some cases where they deviate from the Arrow format because it's more performant. And then we look at that research with the Arrow project and go, well, we want to maintain relevance. We want it to still be zero copy if we can make it that way. And so we have a feedback loop. Arrow recently added new data types to the Arrow spec to keep up with the research and the performance we're seeing. We added new types for run-end encoding, string view for out-of-order string manipulation, and very fast, short inline strings, and so on, because those were the representations that DuckDB and Velox used, which had good reason to use them because of performance. So we took that feedback, we worked with it, and we built it into the spec, into the format, from that community feedback, because we want to keep that zero copy transfer where we can. There's new standards being created using Arrow for geographical data, GeoArrow, GeoParquet, leveraging the Arrow data types and the Arrow usage to improve systems and build new tools and utilities built on top of Arrow to leverage it. It's a whole feedback loop. We need the community and the people that use Arrow, that like it, that benefit from it, that want the performance and the uses to use it. And if they find flaws in it, report them. If they find a better way of doing something, become part of the project. And that's the other reason why I'm here. Aside from getting it well known, aside from getting it used, aside from wanting the standard to proliferate, we need help. I want people to join the community. I'm on the PMC, yeah, okay. Well, I want more people to join my community, sure. But it makes the whole thing better. And it makes the entire data ecosystem more performant and more useful and easier to use, because interoperability is the name of the game. Composable modular data systems is the name of the game. If you're an architect building a system, you don't want to be locked in because this system uses this data format and it's a whole ton of work to swap it out with something better. If it uses Arrow and the thing you can swap it with uses Arrow, now your system is much more composable and modular, and you can be more flexible and more scalable. Okay? So here's my call to action, what I want from people. Use it. Use Arrow, use the libraries, use the tools, use the utilities that you're already using that leverage Arrow under the hood. Then contribute. Contribute to that project that you like, contribute to that project that uses Arrow, contribute to the Arrow project itself or one or more of its sub-projects. It doesn't have to be code, it could be documentation. God knows we need help with more documentation because it's a very large community and it runs fast, and we need more examples and tutorials and things. Documentation is important. Join the mailing lists. There's a dev mailing list for developers that are developing Arrow itself or developing new things in it. There's a user mailing list. If you're just using Arrow and you have a question or don't know how to do something or want to do something more efficiently, go to the user mailing list. Both are very active. We're very friendly people, trust me. And very knowledgeable and will help. Okay, if you're not adopting something, if you do adopt it, you're not adopting something that's going to get you in the hot water down the line. It's a very, very active community. Feedback is important. And then once you do that, if you join the community or if you use it or both or whatever, we all benefit and we all profit from that. We all benefit from better, more useful standards, a better data ecosystem, a more efficient ecosystem of utilities and libraries and tools and protocols and standards. And it's all open source. So if you want more information, if you want to learn more about Arrow, if I've piqued your interest, I really hope so. If I piqued your interest, check out the GitHub repo or one of the sub-projects. Check out the Apache Arrow documentation. There is a ton of documentation. Get my book, I explained the whole format, give lots of examples and utilities. It's very helpful. If you have questions, find me on the floor, find me around. I'm here today and the rest of tomorrow and into next week. Well, till Sunday. But find me, talk, let's chat. Find me on LinkedIn, find me on Twitter. I refuse to call it Elon Musk's thing. Just come see me. Let's talk, let's chat, ask me questions, use Arrow, become part of the community, please. And then, thank you. And it looks like I have 5 minutes. Any questions right now? Yes. Thank you. Oh, absolutely. So if you primarily are working with smaller data sets, you're probably not going to see that much of a benefit, because Arrow is at its best when you're using Arrow through a whole system. But its benefits scale up. The larger the data you're working with, the more beneficial it is. If you are pretty much only working with smaller data sets, changing one piece of your system to use Arrow, it's probably not going to be worth the engineering cost to do it, unless the interoperability you might get out of it becomes more useful. Or unless that's the first piece of a wider, like building it through the whole system. But if you're really working on a system that is very, very one row at a time transactional, you want all the columns of one row at a time, and you process it one row at a time, small data sets, then yeah, Arrow is not going to be that great for that. Yeah. Anyone have a question? Yes. So for the first part, you asked if there's C# connectors. There is a C# Arrow library implementation, which is currently being contributed to. And there is a group of guys from Microsoft that are contributing ADBC C# implementations. So there is a very active build right now of building out the ADBC support for C#. And those same guys are also contributing to the Arrow C# library itself. Whenever they come across features that aren't in the Arrow library, they push them upstream. So there is, more recently, it's become much more active on building the C# support. There is not currently a MongoDB connector that I'm aware of, but that would be a great thing to add. No problem. Any other questions? Yeah. Mm-hmm. Absolutely. So one great example aside, so in the first part, if you're taking data from the Python side and passing it to the Spark side, there's always going to be benefit using Arrow. But on the second side, UDFs. UDFs become hugely beneficial to use Arrow because you can get vectorized UDFs that are benefiting from writing it using in Python with pandas. And what happens is it passes Arrow record batches to your vectorized UDFs. You can operate on the whole thing at once, get the vectorized instructions, pass the record batches back out of the UDF, and then Spark will convert it back into the row-oriented thing that Spark does for its stuff. On top of that, it also depends on what else you're doing in the Spark jobs, which will determine how beneficial it will really be. If Spark's Java side data manipulations are not currently using Arrow to my knowledge, and you're not going to benefit that much on that side to my knowledge. But the interoperability and interaction part, you can really benefit from, especially when it comes to the way Spark does planning and the way it handles data frames. There's a great example in my book of using Spark's spark.read.parquet versus using the PyArrow Parquet library, reading that in and using create data frame from that. And the difference is immense. Anyone else have any questions? Yes. The PyArrow library is essentially a thin shim over the C++ Arrow library. When you allocate, when you're in Python using PyArrow, and you create an arrow array, an arrow table, record batch, arrow buffers in Python, it's being allocated using the C++ code. And is separate, and the Python object that holds the references is garbage collected. But if you pass it across, the PyArrow library handles the reference counting for you. And so you can pass the pointers to the raw data buffers across the boundary safely. And it manages the references and the lifetime for you. And we are also adding a new protocol to assist with that. It's currently experimental and new, a Arrow C export, Arrow C schema export protocols to make it easier for libraries that want to use Arrow as their internal message data passing without having to rely on PyArrow themselves. They would be just exposing the Arrow C header structs to have the data formatted in the right way. Any other questions? Well, looks like I'm a little bit over, so that's it. Thank you. Thank you very much.